sa monosaccharides, we'll proceed to our disaccharides. So, yung kanina, di ba, meron tayong glycoside formation. So, eto na yon. So, ang glycoside, balikan natin, is an acetal produced when monosaccharide hemiacetal is treated with an alcohol and an acid catalyst. Okay. So, meron tayong iba't ibang mga glycosidic bond. So, let's have the 1-4 link na tinatawag. 1-4 link is a glycosidic bond between the carbon 1 or the first carbon of the first sugar and the OH at carbon 4 of the second sugar. So, the glycosidic bond to an anomeric carbon can be either alpha or beta. At nag-iiba ang name ng dalawang disaccharides na to. So, let's have ang sugars, ang disaccharides that has 1-4 link ay ang ating maltose at ang cellobiose. So, let's have first the maltose. Maltose consists of 2 alpha-D-glucopyranose units joined by a 1-4 alpha-glycosidic bond. So, ito yung ating maltose. Ito yung ating alpha. Okay, wait. Ayan. So, ito yung ating alpha-D-glucopyranose. 2 units yan. Ayan. So, sabi dyan, meron daw tayong 1-4 glycosidic bond. Asan yung 1? So, ito yung carbon. Ito yung first carbon ng ating isang unit ng ating glucose. Tapos ngayon, nag-bond siya doon sa oxygen na nakakabit sa carbon ng sa carbon 4 ng ating second unit ng glucose. So, yan. So, meron naman tayong cellobiose. So, cellobiose is the disaccharide obtained by partial hydrolysis of cellulose consists of 2 beta-D-glucopyranose units joined by a 1-4 beta-glycoside bond. Ayan. Ito siya. Beta. Papansin nyo na may mga similarities ang structure ng ating maltose at cellobiose. But cellobiose and maltose have dramatically different biological properties. Ito, mapapansin nyo, ang cellobiose ay naka-beta. Ayan, sorry. Ayan, naka-beta siya. So, samantalang ang maltose ay alpha, pababa, 'di ba? So, ang cellobiose, we cannot digest it. Humans cannot digest cellobiose, and they cannot be fermented by yeast. Kasi nga may nasa may sa beta form. And maltose, however, is digested without difficulty and is fermented readily. So, yun. So, next we have the lactose. Lactose contains D-glucose and D-galactose joined by a beta-glycosidic bond between carbon 1 of galactose and carbon 4 of glucose. Yan. So, ang lactose is a disaccharide that occurs naturally in both human and cow's milk. And it is widely used in baking and in commercial milk formulas for infants. Kung kanina yung ating, what do you call that? Yung ating maltose ay same unit ng glucose, yung 2 units of glucose, so same unit ng monosaccharide. Dito sa lactose natin, meron siyang 2 different monosaccharides. Meron siyang glucose at galactose. So, ito yun. Ito yung ating glucose. at ang ating galactose. Ayan. At ito yung beta-glycosidic bond between the first carbon ng ating galactose and the fourth carbon of glucose. So that's lactose. Next, we have the sucrose. Sucrose, or the ordinary table sugar, is probably the most abundant pure organic chemical in the world. So whether from sugar cane or sugar beets, and whether raw or refined, all table sugar is sucrose. And sucrose is not reducing sugar. Hindi siya reducing sugar kasi isa lang naman ang unit ng monosaccharide niya. At ang fructose ay isa din. Ketone, diba? Okay. So, sucrose is a mixture of glucose and fructose joined by a glycoside link between the carbon 1 of glucose and carbon 2 of fructose. Ito yung glucopyranoside and ang ating beta-fructofuranose. So, kung meron tayong monosaccharides, disaccharides, we have the polysaccharides. Polysaccharides are complex carbohydrates in which tens, hundreds, or even thousands of simple sugars are linked together through glycoside bonds. Ang polysaccharides aren't reducing sugars. Ang cellulose and starch are the two most widely occurring polysaccharides. So let's have first the cellulose. So cellulose consists of several thousand of D-glucose units linked by 1 to 4 beta-glycoside bonds like those in cellulobiose. As you can remember, ang cellulose natin primarily exist in plants, so in their cells. So they are the reason why leaves, the roots, the stems are rigid. They are the structural material to impart strength and rigidity to plants. Ayan siya. Naka-beta-glycoside bond siya. Ayan. So we have also starch. The starch can be separated into two fractions, the amylose and amylopectin. Also, ang starch ay consists of thousands of D-glucose units linked by 1 to 4 alpha-glycoside bonds. Kanina, ang cellulose ay beta, etong starch ay alpha. So, ang amylose accounts for about 20% by weight of starch and consists of several hundred glucose molecules linked together by 1 to 4 alpha-glycoside bonds. Samantala, yung ating amylopectin accounts for the remaining 80% of starch and is more complex in structure than amylose. So, unlike cellulose and amylose, which are linear polymers, parang dire-diretso lang, ang amylopectin contains 1 to 6 glycoside branches approximately every 25 glucose units. So, every 25, so ika-25th, ayan, merong 1 to 6 glycoside bond. Yung ating carbon, yung 6 carbon natin, ay nag-a-attach doon sa first carbon ng isang isang glucose. So, ganun siya. Tapos, ito na naman, 1 ka na naman dito. Tapos, yung ika-25, meron na namang 1 to 6 glycoside branch. So, ang starch natin is digested in the mouth and stomach by alpha glycosidases. Ayan. Alpha letter S to. Sidases. Ayan siya. Yan yung enzyme, no? sa ating, ang tawag nito, sa ating mouth din. So, yung starch na yon, yung alpha glycosidases, dinadigest siya sa mouth and stomach ha. Yung sugar, dinadigest ng alpha glycosidases yung starch na kinakatalyze niya yung glycoside bonds by hydrolysis and release individual molecules of glucose. Like most enzymes, ang alpha glycosidases are highly selective in their action. Namimili lang sila kung saan lang yung kanilang i-digest. So, they hydrolyze only the alpha glycoside links in starch and leave the beta glycoside links in cellulose untouched. Thus, kaya hindi natin nadadigest yung grass at yung mga leaves kasi nga meron silang beta na glycoside bonds. Nadadigest natin ang potatoes at yung rice, yung mga grains natin. Bakit? Kasi meron silang alpha glycoside bond. Okay? Yung ating alpha glycosidases sa alpha glycoside bonds lang nag-hydrolyze or nagda-digest. Kaya minsan, 'di ba, pag kumakain tayo ng kangkong, ayan, 'di ba, minsan lumalabas sa atin kangkong pa din. Yun pa din, hihilahin mo pa. Hindi, joke lang. Okay. Yuck. So, let's have glycogen. Ang glycogen is a polysaccharide that serves the same energy storage function in animals that starch serves in plants. Glycogen are dietary carbohydrates that not needed for immediate energy are converted by the body into glycogen for long-term storage. Glycogen contains a complex branching structure with both 1 to 4 and 1 to 6 links. So, parang parehas lang kanina sa amylopectin. So, ito yung mga hexagons. Yan ay mga glucose units yan. Yung hexagons na yan. So, meron din tayong iba pang mga importanteng carbohydrates. So, itong mga other important carbohydrates naman ay mga hindi sila simple aldoses or ketosis lang. So, let's have the deoxy sugars. So, ang deoxy sugars have an oxygen atom missing. So, ang OH group, ayan yung nandito. Ang OH group natin, ayan, ay nawawala at meron lang siyang hydrogen lang. So, the most common deoxy sugar is the alpha D2-deoxyribopyranose, a monosaccharide found in DNA. Yan. I-note nyo rin na ang 2-deoxyribopyranose na to exists in water solution as a complex equilibrium mixture of both furanose and pyranose form. Okay? So, ang deoxyribose, pwede siyang mag-exist, 40% exists as in a pyranose form and 13% exists as a furanose form. So, another important carbohydrates are the amino sugars. Amino sugars have an OH group replaced by NH2. Ayan, ng ating amine. Ayan siya. So, yan. Ang ating example is the beta-D-glucose amine. Ang amino sugars that are known are the streptomycin and the gentamicin. So that ends our discussion about carbohydrates. So next up is the amino acids, peptides, and proteins.